Hey guys, looking at another problem here from 6.3. The second part there, page 378. We're going to take a look at problem 33, which starts off looking like this. 4 over 1 plus the square root of 3. So again, we have to rationalize that denominator. We can't have any square roots in the denominator. So when that is a binomial, we have to multiply this. Again, we're going to multiply the same thing top and bottom because we're just multiplying it by 1, so we're not changing anything. But the key thing is, what do I want to multiply it by to get rid of that radical? And it's what's called the conjugate of this. And the conjugate is real simple. Change that operation to its opposite, the operation in the middle there. So 1 plus the square root of 3, the conjugate of that would be 1 minus the square root of 3. All right, and I'm going to do that on top and bottom. All right, because again, this is just 1. All right, that's all that is. And so I'm taking our original expression times 1, so I'm not changing it. But let's watch what happens. All right, so up top, this is just the distributive property. All right, I want to do 4 times 1, that's 4, and minus 4 times the square root of 3. All right. So nothing too interesting happening up top. The bottom, again, if you want to use FOIL, I will judge you for that. All right, but I prefer the double distributive property. So again, I'm going to multiply 1 times both of those things. All right, so 1 times 1 is 1, and 1 times the negative square root of 3, or I'm just going to keep that a subtraction sign, is minus 1 times the square root of 3. And now I'm going to distribute the square root of 3 through to both of these. So the square root of 3 times 1 is positive 1 square root of 3. And a positive times a negative, square root of 3 times the square root of 3. Again, those are both square roots, so I can multiply those. I can multiply the radicands, and I get the square root of 9. So again, up top, not really much I can do with that at this point. So the top is just going to stay 4 minus 4 times the square root of 3. On the bottom, I get like radicals here, so I can combine those by adding the coefficients, for lack of a better word. But I've got negative 1 square root of 3 and positive 1 square root of 3. Those zero out, which is what we wanted. That's why we did that conjugate. It's kind of like the difference of two squares. Those middle terms are going to zero out if the only thing that's different is that sign in the middle. And now I've got 1 minus 3. Square root of 9 is 3. So 1 minus 3, that's negative 2. All right. So if you got to that point, I'm good. All right. That's an okay answer. That's a good answer. But if you want to match the answer that I had and just give me the best answer, I've got 3 terms here, and they're all divisible by 2 or by negative 2. Depending on how you look at it. And then I'll take either one of these answers. To be honest, I forget what I shared in the answer document. But if we divide each of these by 2, I would get 2 minus 2 times the square root of 3 over negative 1. All right, that's okay. All right. Or if we divide them all by negative 2, this would be negative 2 plus 2 times the square root of 3 over 1, which really we don't put things over 1. All right. So again, yeah, this is a good answer. This is a better answer. This, to be honest with you, is probably the best answer just because it's simplified more. I don't have any more denominator. I've taken care of that negative 1. But again, I will take any one of these 3 answers here. All right. This is good, better, but that's the best. All right. So again, but the key thing here is when I've got a binomial that involves a radical in the bottom, to eliminate that radical, I've got to multiply top and bottom by what's called the conjugate. And the conjugate is just change that sign. If that would have been subtraction, I would have changed it to addition. Since it is addition, I change it to subtraction. So this is number 33 on 6.3. Hope that helps. Let me know if you guys have any other questions. Take care, guys.